Hi, I'm Cherie Bloomfield and I chose the cervical cancer risk factors dataset. This dataset is a multivariate dataset that focuses on the prediction of a diagnosis of cervical cancer. Cervical cancer is the growth of abnormal cells in the lining of the cervix and is the fourth most common cancer affecting women worldwide. The goal of this project is to understand if a prediction of cervical cancer can be given to a high degree of accuracy. A thorough pre-processing was completed. The data errors that were encountered were inappropriate data types. There were lots of missing values that were replaced to null values and filled and deleted or deleted. Interesting results within the data set showed that most patients did not have cervical cancer diagnosis. Also, most patients did not have a diagnosis of HPV. There are patients with a diagnosis of cancer, but without a diagnosis of HPV. This may show a false negative with the result of the HPV diagnosis, as research shows that virtually all cervical cancers are caused by HPV. One of the models that was selected for this type of data set is the K nearest neighbours classifier. The data was scaled, and as a first testing value, one was chosen as the KNN classifier value, and the accuracy of the model checked to show the predicted and actual result. It was then hypertuned to ensure the most accurate KNN classifier value is used. Also selected was the decision tree classifier, which is a construction that breaks the dataset down into smaller subsets, eventually resulting in a prediction. The decision tree classifier object is created and trained. An accuracy score is then tested, asking how often is the classifier correct. A visualization of the decision tree classifier is also created. The data was split into 50-50, 60-40, and 80-20 splits for test and train. Using KNN equaling 1 showed consistently high accuracy. However, using this KNN may mean each sample is using itself as a reference, and that may lead to overfitting. Therefore, based on the risk of overfitting, KNN equaling 1 would not be the best fit for the model. A split of 50-50 and a KNN classifier value of 4 gave a high accuracy value of 0.9917, and equally high values for precision, recall, and F1 score. It was deemed that this was the best model. Looking at decision tree across all three data splits, the model nominated 5 as the accuracy depth. The split of 60-40 results in 0.995 accuracy, and this was felt to be the best model. Comparing the 50-50 split with the KNN classifier value of 4 model and the decision tree classifier 60-40 split with the accuracy depth of 5, it was felt that the decision tree model would be the best model. This is due to the higher 0.995 accuracy level.